If we want to explore the unknown world outside the solar system and even inside it, traveling at the speed of light can be one of our best solutions. But if we can also travel at the speed of light, what would this trip be like? Stay with us. Hello guys, welcome to Like Ocean family. In this episode we're going to talk about what would happen if we travel at the speed of light. Most of us are excited to see space, movies and movement of humans between galaxies. But the reality is the distance between galaxies is so great that such trips are still limited to the same movies. Because going from our galaxy to another galaxy requires speed close to light. New science says that it is impossible to achieve such a speed. But if it is assumed that we can achieve such a speed, how would we travel at this speed? The speed is exciting for us humans, and it is something that cannot be denied. Ever since our ancestors invented the wheel, this speed has been beyond the capabilities of our legs, and since then we have constantly strived to increase the speed of our transmission. In today's modern age, we have developed very fast objects, super fast airplanes, supersonic fighters, high-speed trains, amazing cars, and spaceships are part of our efforts to realize that dream of greater speed. But we still have an unattainable dream: move at the speed of light. Most of us know that such a thing is apparently not possible, but let's talk about it in a little more detail. Will space travel at the speed of light ever be possible? Let's start with some basic questions. The idea of traveling at the speed of light is attractive to science fiction writers. I cannot read the speed of light, but I'm gonna count it. The speed of light is 299792458. At that speed, you could orbit the Earth more than 7 times a second, and humans could eventually explore beyond our solar system with it. In 1947, humans surpassed that much slower speed of sound for the first time, paving the way for the Concorde, commercial jets, and other supersonic aircraft. With these preparations, will it ever be possible for us to travel at the speed of light? Based on our current understanding of physics and the limitations of the natural world, the answer is unfortunately no. More than 100 years ago, on May 29, 1919, Einstein's theory of general relativity was confirmed. Even before that, Einstein had developed the theory of special relativity, which revolutionized the way we perceive light. To this day, the theory provides guidelines for understanding how particles move through space and creates a key area of research to keep spacecraft and astronauts safe from radiation. The theory of special relativity showed that light particles, photons, travel at the constant speed of 670,616,629 miles per hour in a vacuum, speeds that are extremely difficult to achieve and impossible in the environment. However, throughout space, from the black holes to the near-Earth, medium particles are actually accelerating to incredible speeds. Some even reaches 99.9% the speed of light. What will traveling at the speed of light be like? Now let's go back to our first question. If we can travel at the speed of light and, for example, go to space, what will this trip be like and what will happen? Let's answer this question with a series of prepositions. In Einstein's law of special relativity, there is a law called the dilation, that the faster you move, the slower time passes for you. What does it mean? Imagine that you have a book, a compartment in an express train, and you live your whole life in a moving train. Time will run slower for you than someone living at home, and in plainer terms you will stay younger, although the differences will be on the non-second scale. So based on this scale, if you can move at the speed of light, time will not pass for you at all, and you will remain in the same time as you started moving. So if you go on a light speed space trip to another star, when you come back, none of people you knew when you left Earth might be alive. It is very strange, isn't it? Traveling at the speed of light will also result in certain visual consequences, which is known as the skew phenomenon, which describes a condition in which the passenger's field of vision will turn into a small tunnel-like space in front of the spacecraft window. This phenomenon occurs because light, photons, even photons behind the spacecraft, are seen from the opposite direction. Thank you guys for watching. Don't forget to share your opinion to us in the comments, and it's our pleasure to have subscribed our channel and watch our videos. Here you are guys, we recommended movie and book for today. So for now, I love you and take care of yourself. We'll see you tomorrow, and goodbye.